Example, okay, so ito na po yung example. Assuming here that the assumptions are satisfied. So we have this homogeneity variances, normality, and independence of errors, and this additivity, okay? And then for these four applications, okay, they were compared, okay, in a variety of corn. So in terms of yield, 16 plots were positioned 4 by 4 in experimental area. Okay, so my 4 by 4, if you can imagine the experiment, it's believed that soil has texture. Okay, so it could be yung clay, ilang percentage ng clay, okay, or until dun sa anong percentage, yung lesser percentage of clay. Example lang po. And the moisture gradient. So siguro yung first level ay hindi masyadong, wala masyadong moisture. Okay, and then to this level na mas may moisture. So we have this moisture gradient and texture or soil texture gradient. So this can be now your blocks that can affect the yield of this, of the responses, I mean. And then this is used as the basis to incorporate two blocks again in your current experiment. So we have this treatment, row classification, column classification, experimental unit, and the response variable. So I think naintindihan naman siguro kung ano yung treatment, kung ano yung row dito, okay, yung column. Okay, so it depends on the researcher kung ano yung i-assign niya sa row and kung ano yung i-assign niya sa column. So in this example, I assigned the row, the texture or the soil texture gradients as row, okay, row factor, and then the moisture gradient as the column factor. Okay, then these are applied to plots, kaya yung plots yung experimental units. Then the response is the yield. Now, if we have this raw data, okay, as you can see, may blocks, okay, for moisture, okay, kaya column factor or moisture, kaya you can see there columns 1, 2, 3, 4. Then for the texture, we have this row factor, okay, so every row. So 1, 2, 3, 4. Okay, and then we have these treatments here, okay, T1, T2, TC, T4. Parang na-summarize niya lang kung ano yung mga responses. Then we can see the row total, the column total, and then the total for each treatment. Okay, now using star, you can have this output here. As you can see, source of variation is now has significant result. You can see only the row factor, no, that differs, no, in terms of the means. Okay, so if we have this ANOVA table again, okay, you can have the F or the P value, no, to decide. And then, okay, so we can now use, okay, we can now test now for the differences among the treatments. Okay, correction lang po, ito po ay formulations. Kasi yung example natin ay nitrogen applications. So dito po ay among nitrogen applications, hindi po varieties. Okay, so there is no difference in the mean yield among applications. So that's your HO, no difference. Then HA, at least one of the applications yielded the different mean yield or result. Okay, then you can use again the F kapag na-satisfy yung assumption. And then you have this, okay, so I showed this to you already. And then the test is statistic, we have 0.6, so this is actually, okay, the value here in the ANOVA table, so 0.6. And then the p-value, if you use the R, you can, the star, you can have this p-value, 0.639, and you can compare this to what? To the value of the set level of significance, 0.05. So if 0.6 is greater than 0.05, therefore, okay, there is no enough evidence to say that at least one of the application has a different mean yield. Okay, so wala na iba, no, among these three applications or three treatment levels. Now, next is the test for the row factor. So if we consider row as our yung soil texture gradient, okay, as our row factor, so HO now is no difference among the texture level versus the HA, at least one of that texture level has a different mean. Okay, ganun pa din, nag-vary lang po sa F kasi yung numerator is for the row Okay, and then you can go back to the star output and check. Okay, the p-value there is 0.027. Okay, ito po. And so there is enough evidence to say that at least one of the texture levels has a different mean yield. So nag-iiba pala yung texture levels. Okay, dun, in terms of the means. And then another is no difference in the yield among moisture levels. So ito yung column factor natin, yung moisture level. So that's your HO. Then HA, at least one, okay, has or have a different mean yield. Okay. And then F test, ganun pa din. Yung ratio natin, the numerator has this MSC, okay, for the column factor. And then we go back to the result using star. We have this 0.692 as our p-value, and we compare it again to alpha 0.05. And then there is no sufficient evidence to say that at least one of the moisture levels has a different mean yield. Okay. So it's okay, no? At least in this example, pwede na hindi mag-differ yung treatment levels, pero yung row factor or yung isang block ay mag-differ. So it's okay. Now, to check the efficiency or the relative efficiency of this LSD over the CRD, okay, we have this formula. And then, ganun pa din. If it's greater than 100%, then we can say that LSD is more efficient. And if we have this value less than 100%, then we can say that CRD is more efficient. Okay? And then, okay, so just to continue, given this formula, we have this ANOVA output. So we just plug in the values. So yung mga nasa, what's this? So where is that 0.008? The mean square, okay? The mean square for the column factor, we have this MSC, okay? Yan. And then the MSE, the 0.0016, this one here. And then the MSR, okay, the MS for the row factor, we have 0.0099. Okay, and then after plugging all the values, we can get the result now, which is 193.75%. So that's way higher than 100%. Therefore, mas efficient yung LSD. So the computed relative efficiency is more than 100%. Thus, the added variation of the blocks resulted to gain in precision. Thus, LSD is more efficient, okay, than the CRD by about 2 times, kasi almost 200%. Okay, so now I think we're done. So this is now the summary. First, we had this basic concept, so the terms, the principles, and the design structures. So you were introduced with the different design structures and treatment structures. And then we also had this CRD, then RCBD, then LSD. And then final note, okay, statistics when properly used makes efficient research. However, it is not a remedy for poor conceived or badly executed research. Thus, it is essential that a user of statistics clearly understands the techniques he employs. Then, in case po may consultation po, I would like to introduce this statistical consulting group, which I am also a member. Okay, so sometimes we have this free consultation. We do this nationwide. Okay, last year, so every anniversary, or like every special occasion of Instat, we have this free consultation. But yun nga po, there's a possibility that there will be another free consultation. Or in case po, you can visit this website here para po sa on more details